Now, moving on to equivalence relation, which is simply a relation that is reflexive, symmetric, and transitive. And we say that two elements that are related by an equivalence relation are called equivalent and denoted as shown below. Symmetric is A equivalent to B whenever B is equivalent to A. Transitive, where if A and B are equivalent and B and C are equivalent, then A and C are also equivalent. Reflexive is every element is equivalent to itself. Let R be the relation of the set of real numbers such that A relation B if and only if A minus B is an integer. Is this an equivalence relation? Number 1. Reflective. A relation A must be A minus A where the number should be integer. A minus A is equals to 0 where it is an integer. Thus, it is reflective. Number 2. Symmetric. A relation B must be equivalent to B relation A where A minus B is equals to C and B minus A is equals to negative C. Since both have C with different sign, thus it is symmetric. Number 3. Transitive. A relation B and B relation C is equivalent to A relation C. Must be an integer. Since A relation B and B relation C is an integer, thus A relation C is also an integer. Thus it is transitive. Equivalent classes, where the set of all elements equivalent to an element A of A through equivalent relation R is called an equivalence class A1, denoted as below. From the question and answer below, we can simplify that the element of set A, which is A and negative A, is integer and the pattern is repeated. Partition. A partition of a set S is a collection of disjoint, non-empty subsets that have S as their union, where it means there must be no empty sets, there must be no overlap, and all elements are included. The partition show odd number and even number that is denoted by A1 and A2. From the question and options available, the answer is P2 because there is no empty set, there is no overlaps, mean there is no repetition, and all elements are included. The properties. If R is an equivalence relation on a set S, then R can form a partition of S. Conversely, a partition of S can also form equivalence relation R.